Yes. Okay, let's get started. First of all, Happy New Year. I best I wish us the best to you in the new year, and very welcome to the new to this course. I'll be grateful if you mute yourself. There are some noise. Actually, I think I can mute myself. Yes, I did. Good. Welcome to this course, Advanced Optimization and Game Theory for Energy Systems. My name is Jalal Kazempour. I'm an associate professor at Technical University of Denmark, DTU. I taught this course, I don't know, 5, 6 times in previous years, but it's the first time that I'm running this course online. So hope we will have a very good experience with this new format of the course. Good afternoon for those who are in Europe, in Denmark. Good morning for those who are joining from United States, from Canada, maybe from South America. And also good evening to those who are joining, I don't know, from Australia, from China, from Singapore. I hope we will have a good course in the coming 3 weeks, and you will learn some materials about optimization and game theory for power and energy systems. Well, I hope you see my screen well. So let's start. This is the link, the Zoom link for all lectures. So during the all 3 weeks, we will use the same link with the same password. So we will not have a new Zoom link in the coming lectures. Yeah, some suggestions about the online teaching. Please always mute your microphone and only unmute while you're speaking. If you have questions during the online lectures, like now, you have 2 options. The first one is that you can write in the chat box. So then I can read your question and will answer. The other option is that you can write in the chat box that you have a question, just that, and then I'll invite you to unmute and ask your question when the time is right. Well, some practicalities. I suppose you already got username and password for DTU Insight portal. It looks like this. And here in the message, here in the message, you will get all the emails about the video links. Then in the file sharing, all the slides will be uploaded. So you can suppose to get all the slides before each lecture there. Then in the assignments, you can upload your projects. I'll talk about the projects later. Well, just a second. I have a technical issue here in my screen. It's frozen. Sorry. Just a second. Sorry, I have to stop sharing and share again. Sorry for that. Sorry, I think I need to restart my Microsoft Surface and join later. So just 2-3 minutes break. I'm so sorry for that. Yeah, I was, sorry for that. So yeah, I was saying, so we have a message, file sharing, and assignments in the DTU Insight portal that you can use for getting all the message, to get all the slides that I upload before each lecture, and to upload your assignments. Well, So I already shared with you online Excel sheet. Before lecture, I saw that almost 90 students, they already insert their information. So if you haven't done it before, so please add your information. So I will have a good idea about the distribution of the students from all over the world. Yeah, yes. So we will have three types of the sessions in this course, including lectures, exercise sessions, and Q&A. So in the lectures, yeah, I'll teach different, I mean, different parts of the course. We will have exercise sessions. So that's the idea is this. During each lecture, we will have a few small exercises. Then you will be kindly asked to work on those exercises yourself. You don't need to provide any report for the exercises. They are just some materials to support the education. So the next day, the first session will be exercise session. So in that session, we will talk about the exercise, the solution, and if you have also any question about the content of the previous lecture, that's the time that you can ask your questions. I really encourage you to be active during the exercise sessions. If you have any solution for the exercises, you are very welcome to share with others. You can share your screen and yeah, and describe your solution. Or if you have any question or any discussion, you are very welcome to join. Also, we have the third type of the sessions, Q&A. Um, so that's the time slides that I'll be available online. So if you have any question about the course material, it's not only about the last lecture, any lecture during the course, you can ask your question. Or if you have any question about the projects, your projects, then you can ask your question in the Q&A sessions. Or if you like to hear the questions of others, again, you are welcome to join. But if you don't have any question, then you can skip the Q&A sessions. So about the recording, every single session will be recorded and the link on Dropbox will be shared with you. But yeah, so you will get all the videos and also the lectures, but not the exercise sessions and not Q&As. They will be finally publicly shared on YouTube. So this is the course agenda. The first day, January 4, today we are going to talk about, um, yeah, we will talk about the market clearing as an optimization problem. We will have three sessions every day. So the first one is from 3 to a quarter to 4. Today is the course introduction, but the other days it will be either exercise session or Q&A. Then the second session, again, it will be maximum 4 to 5 minutes. It will be lecture part A. And then the third one would be the lecture part 2. We will have 8 Q&A sessions. And as I said, all the first sessions every day, except for the days for Q&A, we will have exercise sessions. So we have a question regarding questions about projects. Do you prefer? Yeah, I prefer the questions to be asked during Q&A. But if you couldn't manage to ask your questions, then you are more than welcome to send me an email. Yeah, so I will teach 11 lectures, but there's only one specific lecture about the number L4, about cooperative game. That one, my colleague, Dr. Liang Han, will teach that specific lecture. I'll introduce Liang later before starting lecture 4. So about assessment, well, I used to have oral exam for this course, but now it's online and there are, I mean, 120 attendees in the course, so it's really hard to have oral exam. So the assessment will be only based on course project. We will have 4 steps for the final project. I'll explain each step later in a few minutes. All the projects should be done individually. So each student needs to provide 4 reports, 1 report per step, right? After receiving your reports, you can expect to receive feedback from my side. I don't promise to get back to you the day after you send me your report, but I'll get back to you as soon as I can. So you will send me 4 reports, each of you, and the weight of each report in your final grade will be 25%. So they will be weighted equally. I'll talk about report template and content later in the next slide. Also, I'll talk about the deadline for each report later in the next slides. There's a question. Let me check the chat box. Is there anyone having problems listening me? Yan asked. Yeah. So Drake said that it's fine now. Okay. Sorry, Yan. I hope you can hear me well now. Good. Um, yeah. So Rajan, okay, confirmed that he is hearing nice. Okay, good. Thank you. Thank you. So San said it's good. I don't know if you know about the Danish grading system. It's a bit well, it might be a bit strange for you. We have 7 scale grading system in Denmark. It means that we can only have 7 grades, either 12 or 10 or 7 or 4 or 2 or 0 or -3. So your grade will be one of these 7 grades, ideally 12. Um, so the last two, 0 and -3, it means fail, while all the grades from 2 and above, they mean passing the course. And this is the percentage, how we convert your final grade in percentage to Danish grading system. So if you get, for example, from 92% to 100%, it means that you will get grade 12, which is the best, the top grade in Denmark. Or if you get from 84 to 92, it means that you will get grade 10. Yeah, so it will be fun. You will say that's a nice grading system, I think. Okay, let me talk about your course project. We have 4 steps, but also we have an initial step. Initial step is that you need to pick a convex optimization problem applied to energy systems. This is a PhD level course, so I'll be very happy if this course helps you in completing, for example, your PhD thesis project. So you are also welcome to apply the materials of this course to your specific problem in your thesis or whatever, what kind of, I mean, any type of the problem you have in mind. But the most important thing is that you need to select a convex optimization problem. We are not going to cover non-convex optimization problems in this course. When we are talking about convex problems, the most straightforward version of a convex problems is linear optimization problems. So it's maybe more straightforward for you to pick a linear optimization problem, which is applied to energy systems. It could be power, it could be gas, it could be heat, it could be hydrogen, whatever. I don't mind, but it should be convex. It might be linear, it's fine. But if you like to apply the course materials to a more advanced convex but nonlinear problem, for example, conic program or semi-definite program, you are welcome to also select that. But I have to say that this course, I'll only cover the duality for linear program. So if you pick, for example, a conic program, which is convex but not linear, well, you may need to learn yourself how to take duality, for example. Or if you take STP problem, semi-definite programming, which is convex problem but not linear, again, you're welcome to do that, but you may need to learn yourself, or maybe you know already how to take duality of that problem. So your problem should be convex. It could be linear. it could be a conic program, it could be STP. It's up to you. Um, I prefer that you don't pick a mixed integer uh, problem with either binary or integer variables. But if you need to have binaries for this specific course, because we would like to have convex problems, you can relax your binaries. For example, if you have binaries, it means that the value should be either 0 or 1. You can relax it, making it a continuous variable that lies its value is lying between 0 and 1. Okay. So the bottom line is that your problem needs to be convex. But what kind of problems you can select? It's up to you, but here I provided a few examples. For example, the most common problem in power systems is optimal power flow, OPF. You can work on OPF problem, but it needs to be convex. It means that it should be either DC OPF or it should be relaxed AC OPF in form of conic or STP, whatever it is. It should be convex. Or you can consider, for example, security constraint OPF, or you can select electricity market clearing problem. I will use this problem as the basis for this course, and I'll talk about electricity market clearing a lot during this course. But also you can go for gas market clearing problem or heat market clearing problem as far as they are convex. Originally the natural gas power flow and heat power flow, they are both non-convex, but we have some tricks to make them convex. If you are going to consider those problems, I'm fine. Also, you can go for integrated energy markets, that we clear markets for electricity and gas or electricity and heat at the same time. Also, they can be your problems. Also, you can consider the long-term investment problems like generation capacity expansion planning problem or transmission. But again, we need to not have binaries. So it means that instead of having binary variables selecting this generator or the other generator to be installed, you can consider the capacity as the expansion variable. For example, a generation capacity can be varied between 0 and max 100 megawatt, something like that. Also, you can consider local energy market clearing problem in the distribution level or energy community level, whatever. Or you can go for a flexibility market clearing problem. It could be ancillary service markets in the TSO level, in the transmission level, or it could be DSO level, distribution system level flexibility markets. As far as they are convex, there is no binaries. I'm fine that you can pick them as your problem. Also, you can go for offering or bidding strategy problem, for example, for a thermal generator or for a hydro unit or for a storage or whatever, or I don't know, for a heat pump or for a combined heat and power or for a gas-fired power generator. You can consider offering or bidding strategy problem. In this course, I use offering for the generators while bidding for demands. So for both sides, you need to have offering or bidding strategy problem in the markets. So they also can be your problem in this course. But if you have a specific problem in mind and you are in doubt if it's a good problem to be picked for this course, as long as they are convex, you are welcome. But still, if you are in doubt, you are very welcome to contact me, send me an email, and present your idea. Then, well, we may have a few discussion, and then I'll help you to pick a good problem for the course. Okay, there are two questions. No, there are questions from, yeah, about the sound. Okay, hope everything is clear. Well, after picking the problem, you need to also select a test case. Your test case is expected to be large scale enough. So it's not fine to consider a single generator, two buses, one single line, and 1 hour. It's not large scale enough. So the criterion about the scale of your test case is that in your step one, the problem you will solve, the optimization problem you will solve, it needs to have at least 1,000 variables or at least 1,000 constraints or both. So if you have a problem with 10,000 variables, I'm fully fine, but not 50 variables. And how can we count the number of variables in your optimization problem? Just to get an idea, for example, if we have a single generator and we are trying to obtain its optimal dispatch during a day, and we are trying to get the hourly optimal dispatch, then it means that we have 24 hours. So if we have 10 generators, 24 hours, it's 240 variables. Then we have, let's say, 10 lines. Again, it's 240 variables. So you need to count like that and to make sure that your optimization problem will be large scale enough. But what kind of test case you can use? There are many, many test cases. I'm pretty sure you are already familiar with some common test cases. For example, the IEEE test cases. Here in this link, you can get the information about different IEEE test cases, including 14 bus, 96, 96 bus, 300 bus. I don't remember exactly, but you can check the IEEE test cases there. Also, there's a 24 bus IEEE reliability test system in this link. You can also use that. But if you have any other test case in mind, as long as it provides you a large scale enough optimization, I'm fine. Also, it depends on the problem you pick. For example, if you pick a problem related to distribution system, then these test cases, they are not appropriate. You need to pick a radial test case, right? A distribution system. Yeah, but again, sorry, if you have any question about the test case, you are welcome to contact me. So now step one, as I said, the course project will have 4 steps. This is the step one. Based on the materials you will learn today, January 4, it means that today, after the lecture at 6 p.m. today, at the end of the lecture today, you can start working on course project step one. And the deadline for handing in your report is January 12th. There's a question. Let me check the question. The second link regarding the test case is not working. It might be because of the PDF file. Just copy and then paste, not click on the link. I think it will work. If not, I will check it out and send you later. But I think if you copy and paste the link, it will work. Don't just not click on it. Okay, let me explain about step one because you can start it today. So that's the idea. When you pick a problem, I will call it original problem or primal problem. And as I said, it needs to have at least 1,000 variables or 1,000 constraints. You need to solve it in a programming language of your preference. It could be GAMS, it could be Python, it could be Julia, it could be MATLAB, whatever. You can use any language, any software that you prefer. I don't mind. So you need to solve your problem. You need to write the code and solve your problem. Then today, works now. Good. The link works now. Good. Then you need to drive the formulation of the dual optimization problem. So you have a primal problem. You need to drive the dual optimization problem. And again, you need to solve it in the programming language that you prefer. Okay. Then the third step is that you need to derive the KKT conditions, the corresponding Tucker conditions of your problem. And again, you need to solve it. You can solve it as a system of equations, or you can solve it in a nonlinear way. I will explain about the duality and KKT conditions later today. So you will learn more about duality and KKT conditions. But whatever the problem you pick, you need to also drive and solve its dual problem and its KKT conditions. And then at the end, you need to report the number of variables, number of constraints, the optimal value of objective function, and the optimal value of critical variables. For example, the power production or market prices if you are clearing a market or something like that. And you need to report it for every single problem, for primal problem, for dual problem, and for KKT conditions. As I said, you can start working on it today, and the deadline for handing in your report is January 12th. Step two, you can start working on it from January 12th based on the content of the course, and the deadline for handing in your report is January 22. Um, Again, for the problem you pick, you need to solve it under uncertainty. So step one is deterministic, but step two will be stochastic. You can either use scenario-based stochastic programming, or you can use distribution robust chance constraints. I will not explain in detail right now the different steps because I need first to teach the materials in lecture 5, and then I'll get back to step 2 and will explain more what you need to do in step 2. Step 3, in step 3, you will have two options, option 1 and option 2. You can pick one of them. The first option is to solve your problem as a cooperative game if it's relevant. For example, if you are solving a market clearing problem, it's totally relevant to solve it as a cooperative game. But if you pick it, you need to wait to lecture 4, and then you can start working on step 3 from January 7th. The second option is to upgrade your problem as a bi-level program. For example, if you pick a problem like offering a strategy or capacity expansion planning, it's very relevant to solve it as a bi-level program. I will teach it in lecture 7 or 8. It means in January 14. So you can start working on it step 3 if you pick option 2 from January 14. But the deadline will be January 25. If you pick a problem that none of these options is relevant, you are very welcome to contact me. Then we will find another alternative for step 3. But I'll talk about these options later during the course when I teach cooperative game and bi-level program. And finally, step 4 is about the composition. So again, you need to consider your problem in step 2. It means your problem under uncertainty, and solve it in a decomposed manner, either using Bender's decomposition or Lagrangian relaxation, or a specific variant of Lagrangian relaxation that we will call it ADMM. Based on the schedule of the course, you can start working on it from January 20. And the deadline, okay, if you pick Benders, you can start working on it from January 20. If you pick Lagrangian relaxation or ADMM, you can start working from January 22. And the deadline for handing in your last report is February 5. Hope it's clear. Let me check the chat box. About the constraints of our problem, are they provided in the IEEE together with the variables? No, you need to count it. You need to count it. If you solve your problem in GAMS or Python, you can ask Python or GAMS or Julia to report the number of variables and constraints. But also you can count it manually. For example, if you have, I don't know, 10 generators binding or imposing the minimum production And the maximum production, it means that you have 10 generators times 2 constraints, it's 20 constraints times 24 hours, for example. So you can either count manually or you can ask Julia or Python or GAMS or MATLAB to report the number of constraints. So we have to think what the constraints will be. Yes, yes. So you need to think about the constraints, but also it should make sense, right? If you consider 24 hours, you need to also consider intertemporal constraints, linking the times together. Otherwise, it will not make sense to have 24 hours while each hour they are isolated, they are not connected to each other. If you have any, if you have a doubt about your problem, you're welcome to contact me. But yes, you need to think about your problem, number of variables, number of constraints. Hope I answered your question. Okay, about the template and the content of your report. Remember, you need to hand in 4 reports. So each report should be single column and double space. And about the length, please try to write it as short and as efficient as possible. It should be maximum 5 pages. But if you write in 4 pages, I'll appreciate it. So assume that you are writing like a scientific paper. So it should be efficient. A short introduction will be appreciated, but please not write a very long introduction. Also, you don't need to go to provide state of the art or something like that. Just a short introduction. But it's important to write your formulation in a complete and precise way. You can, if relevant, you can provide a compact representation of your formulation. And the notation, it needs to be defined precisely. Then it's highly recommended to provide the most important results in the form of figures and tables, like writing a scientific paper. And please avoid including trivial results or less important results. So again, it's based on your own evaluation. You have to figure out which outcomes are the most important and interesting to put in your reports. This is the part that I'm very interested in. When you provide results, you need to provide a discussion and elaborate on your results obtained. And then, I don't know, you can discuss the results. You can include some computational analysis like number of variables, number of constraints, CPU time, the specifics of the computer you're solving the problem. If relevant, you can add some policy recommendations or implications. It's up to you. But this part is the part that which is very important and interesting for me. And at the end of the day, when you submit your report, you need to submit a zip file on DTU Insight portal, and your report should include the PDF file of the report and all your codes, either in GAMS or Python or Julia or MATLAB or whatever else. Yeah, that's it. That's all about course introduction. It was a long introduction, and sorry for the interruption, the technical issue in the middle of this lecture. Well, if you don't have a question, we can finish this lecture right now and start again in 20 minutes at 4 p.m. Denmark time. Any question? Yes, please, Rajan. You're welcome to unmute and ask your question.
Hello, good afternoon, Professor.
Uh,
You can
could you
hear
please
me
talk a bit loudly? Could you please speak loudly?
loudly? Okay, can
Yes.
you hear me now?
Yes, yes.
Okay, so I have a mandatory PhD course in my university that I cannot miss, which is contradicting with two of your lectures on 19th and 20th. So is it okay that I don't attend it live,
Yes.
but then later just see the recording? Is it okay, or what is your
Definitely, definitely, definitely. You will have the link for the videos. I don't mind, to be honest, if you attend or not. The important thing is that you follow the course either live or later through the links, the recordings, and then to deliver nicely your reports. That's the most
Reports. Okay.
important things.
Thank you,
Uh,
Professor. Thank you.
Welcome. Eric asked, is there a LaTeX template for the report? No, there isn't.
Latex
You
templates.
can easily find, you can Google and find a template for the reports. As long as it's simply a single column and double space, I'm fine. David, yep, please unmute.
Hi, Jalal. Thanks. Can you
Hi,
hear me?
David.
Um, I maybe I missed something, but
David,
so
could you
the
please talk a bit loudly?
okay. Can you hear me now? Better.
Yeah, well, okay. If I can't hear, I'll ask you to repeat.
So I was wondering whether the project, well, the zip file, maybe I missed something on the line, but the project zip file with the PDF and the code should be
Yes,
submitted for each of the three
yes.
stages or only at the end?
Four stages, four steps.
Four, sorry, four,
We have
four.
four steps, so it means that you will need to have four zip files by the end of the
All right.
course. Each zip file includes the PDF file of your report, max 5 page, and all the codes you developed.
Okay, perfect. Thank you.
Any other question? Maybe share the course link with students that haven't yes, definitely. You can share all course materials. Even I will upload the video of lectures, not exercise sessions and Q&As on YouTube later in January, in late January. So yes, please, you are more than welcome to share the course materials with your colleagues, definitely. No, your TA is me. So the question is that do we have TA sessions for the course? This is exactly why we have Q&A sessions. So in the Q&A sessions, you can ask your questions from to me. I will answer. If you have extra questions, you can send me an email. But if you feel that you need extra sessions, even without me, but the students of the course, they would like to attend and discuss with each other, again, if you think it's a good idea, we can also arrange it. But the idea of Q&A sessions is that I serve as a TA for the course in those sessions. Hope I answered properly your question, Prabhat. Alessio, can we use pre-built software package like Power Models to no. Uh, no. At the end of the day, you need to derive dual problem. You need to derive KKTs. So to be able to do that, you need to write the primal problem yourself. Otherwise, you cannot derive dual problem. You cannot derive KKTs. So the goal of this course is that you understand what is going on in your problem. So when you use an available software, available package like Power Models, then it's a black box for you and you don't understand what's going on there. And as I said, you need to have analytical evaluations to derive the dual variable, to derive the KKT conditions. So at the end of the day, using the available or pre-built software, they will not help you in this course. So my answer is no. Uh, any other question? Okay, Nicholas, if we are using data from Excel to feed the model, should we send Excel files as well? Yes. At the end of the day, I need to see that the model, the code is working. So please send all the code as a package together and make sure that I'll be able to run it. So I will run the code in my computer. So please share with me all the materials. And if it's complicated, you can add a description file like README, and I can read and understand how to run your model, your code. Yanis, in case we do not have a time horizon of 24 hours, but a week of simulation, does the extra variables? Yeah, definitely. Yes, 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 yes. As long as you have at least 1,000 variables or constraints, I'm fine. It could be a daily problem, it could be a weekly problem, a yearly problem, whatever. Saurabh, is it okay to use Express using the Python interface for the code? Yeah, definitely. Yeah, you can use any interface or any solver you like. Yeah, I'm totally fine. Yeah. Any extra question? Okay. Let me conclude the course introduction session here and start the lecture session in 14 minutes at 4 p.m. sharp. Okay, let's have a break and see you in 14 minutes. Bye-bye.